Okay, 1 AMU times Avogadro number is 1 gram. Remember this.
Yeah.
Okay, we have here exercise number 4. We will calculate, we will find the molar masses for the following compounds. Okay, let's start with F. Sodium, the name of this compound is sodium dichromate. This is the chemical formula. Okay, the molar mass of sodium dichromate will be, can you tell me the expression for molar mass of this compound? Okay, 2 times molar mass of sodium plus 2 times molar mass of chromium plus 7 times the molar mass of oxygen. Okay, where can we find the molar masses for these elements? Of course, on periodic table. Let's check their respective molar masses. Let's start with sodium. Sodium on periodic table is here. Look, atomic mass 22.99, let's say 23 AMU. But 23 AMU times Avogadro number is 23 grams. So 2 times 23 grams per mole. For chromium, let's check for chromium. Look, 51.99, let's say 52 AMU, it means 52 gram per mole. And it will be 2 times 52 gram per mole plus 7 times the molar mass of oxygen is 16 gram per mole. Okay, now let's make calculations. Here we have a calculator. So the molar mass of 2 times 2346 plus 2 times 52 is 104. 104, this is 6. Plus 7 times 16, let's check it. 112 plus 104 plus 46, it will be 262. 262 grams per mole. Okay, is it clear?
Yes.
Is it clear? Okay. We have, okay, do you want to see another example? Is the same thing. We only have to calculate. Firstly, we will write the expression, then we will check their respective, we will check the respective molar masses on periodic table, then we will find the sum. Okay, let's continue with 5. Exercise number 5. Find the masses for the following substances in grams. Okay, I will copy this. Okay, we will find the mass if we know the number of moles and the substance. Do you remember how can we find mass if we know number of moles and molar mass? The formula?
Somehow.
Okay, mass is equal with number of moles times molar mass of the substance. M, yes, M lowercase is mass, and uppercase, lowercase is number of moles, and M uppercase is molar mass. Okay, let's calculate B. We have 20 mole of this substance called ethane. N is 20 mole. The substance is ethane. We will find the molar mass. The molar mass for this substance, the expression will be 2 times molar mass of carbon plus 6 times molar mass of hydrogen.
Yes.
Okay, if we check the periodic table, the molar mass of carbon is 12 gram per mole. And for hydrogen is 1 gram per mole. So the expression will be 2 times 12 plus 6 times 1. 24 plus 6 is 30 grams per mole. Okay, what we will find here, we will find M, mass, number of moles times, number of moles 20 times 30 is 600. 600 grams of this substance named ethane. The substance is ethane. 600 grams of ethane. Do you understand it? Treasure? Are you there? Treasure?
A bit there. Sorry.
Okay, do you understand what I did, what I wrote?
Yes, I started. Thank you.
Okay, but
Finish
you
the
must remember this formula, please. It's crucial. This chemical formula. This formula, this formula will follow you always in chemistry. So you must remember this.
Okay.
Oh, we will continue with another exercise. Wait.
Are you hungry? What is your lunch? What?
In this exercise, we will calculate the number of atoms that are in each substance
You can't say
below. Look, let's start with A, the simplest one. A. We have 10 grams of calcium. First of all, we will find the number of moles. The molar mass of calcium is 40, as I remember, is 40.1 gram per mole. Yes, 40.1. gram per mole. Okay, the first step, we will find the number of moles. Number of moles is equal mass over molar mass. Mass 10 grams. Molar mass, let's say 40.1. Approximately 1/4, it is 0.25. 0.25 mole. But in the exercise is asked the number of atoms. So we must remember that in 1 mole of any substance, we have 0.2 times 10 in power 23 particles. Okay, but we have 0.25. What we will do, we will use another formula that is really important. Number of particles is equal number of moles times Avogadro number. Here is asked number of atoms. Since calcium is an element, it is a pure substance. So we have only calcium atoms. And we found N here, 0.25. 0.25 times Avogadro number. 0.25 times 6.02 is 1. Let's say 1.7. 1.7 times 10 in power 23 calcium atoms. This is the answer for the first one. Okay? Is it clear?
Yes, it is.
Okay, now let's continue with B.
Okay.
Because B is more different. Here we have gas. We have oxygen. Okay, what we will do, wait, step 1. In the first step, we will find the number of moles. But what we know the volume of this gas is oxygen. And if you remember, at STP, 1 mole of any gas occupies a volume of 22.4 liters. Do you remember? At STP, okay, we will find the number of moles of oxygen will be volume of the gas over molar volume. The volume of the gas is 44.8 liters. Molar volume at STP is 22.4 liters per mole. Okay, what are we going to find? We are going to find the number of moles. 44.8 over 22.4 is 2 mole. 2 mole of oxygen. But wait, what is asked here? It's asked to find the number of atoms. Okay, we have a molecule here. Oxygen here is a molecule. How many atoms does oxygen have? 1 molecule of oxygen have?
2.
2. Very well.
Yeah.
So 1 molecule has 2 oxygen atoms. So if we have 2 mole here, we will have, look, we will have 4
I finished the homework.
mole
I
atoms
finished the homework.
of
Yes, I
oxygen.
understand it.
Here we have 2 mole molecules. Here above, 2 mole molecules. Oxygen. So it's really important in this type of exercise, is really important to distinguish between molecules and atoms. We have 2 mole molecules of oxygen, but we have 4, and also we have 4 mole atoms oxygen. Why? One molecule has 2, so the ratio is also 1:2. So what we will find in the second step, in step 2, we want to find the number of atoms. So number of atoms is equal number of moles times Avogadro's number. Number of mole atoms is 4, and Avogadro's number is 6.02 times 20 times 10 in power 23. So 4 times 6.02 is 24.8. Let's say 24.1 times 10 power 23 atoms. I will write it better. 23 oxygen atoms.
Yes, we made.
Is it clear? Isn't it?
Yes.
Okay, now C. C is more difficult, let's say.
Because it has to.
Yes. So wait.
Yes,
Okay.
yes, sir.
Okay, we have this compound. This compound is named calcium carbonate. Is a salt. Is a chemical compound.
Yes.
Okay. We want to find the molar mass first of all, because we need the molar mass of this compound. The expression of molar mass will be molar mass of calcium plus molar mass of carbon plus 3 times molar mass of oxygen. Molar mass of calcium is 40.1, we said. For carbon is 12. For oxygen is 16. So 3 times 16. So 3 times 16 is 48. So 48 plus 12 plus 40.1 is 100.1. 100.1 grams per mole. Okay, now let's start with this is first step, step 1. Now is step 2. In the step 2, we need to find the number of moles. Number of moles of this compound. Number of moles is mass over molar mass. Mass 50 grams, sorry, 50 grams over 101 grams per mole. It will be about 1/2.
Yeah, approximately 1/2.
1/2 is 0.5 mole.
Mole.
Hello?
The second step. Okay.
Yep.
Now, in the last step, we want to find the number of atoms. Okay,
Okay.
let's analyze this compound. How many atoms does this compound have? Any idea? You will count the atoms in the formula. Okay, in one molecule, let's say we have one calcium, one carbon, 3 oxygen. 1 plus 1 plus 3 is 5 atoms. Is it clear? Is it clear? Why 5 atoms?
One.
So do you understand it or not? Yes, Treasure?
Yes, I do.
Okay.
X equals 13/8.
Okay, how many mole atoms do we have?
We have 5.
We have 0.5 times 5.
Right, which
Yeah.
is 2.5.
Yes,
5x minus 7.
2.5 mole atom.
Oh my god, I thought I saw 8. Sorry, I'm coming.
Okay, and in the step 3, last step, we will find the number of particles. In step 3, we know number of particles equal number of moles times Avogadro.
Avogadro's number.
3/2.
Yes, 0.5 times 6.02 times 10 in power 23.
12/8, right?
2.5 times 6.02 is, let's say, 15.
Yeah.
15 times 10 in power 23 atoms. So is it clear?
Yes, it is.
Okay, very well.
Yes. Yes. Yes.
Okay,
Yeah.
now we will continue with another theoretical part. Is
God.
okay, the topic, let's say the new topic,
3x
is the mass
equals-
percentage of elements in a compound. Look, the mass percentage represents the percentage of mass of one element of a certain element in the compound. So here we have, in this example, we have a compound. The compound is sodium hydroxide. We want to find the mass percentage of each element in this compound. Remember, always the first step is to find the molar mass of compound. For this compound is molar mass of sodium plus molar mass of oxygen plus molar mass of hydrogen. It's 40 grams per mole. The mass percentage of sodium will be the molar mass of sodium, the ratio of molar mass of sodium with molar mass of sodium hydroxide. Of course, expressed in percent. So I will solve it here because so molar mass of mass percentage of sodium, molar mass of sodium over molar mass of sodium hydroxide times 100%.
2x.
Look, I will write the answer here because I don't have enough space. So
Okay.
23 over
Well,
40 times 100%.
x equals to
Okay,
6.
I will calculate it.
When I solve this the third time, yeah.
23 over 40 times 100%
I
is
solved for
57,
3x.
57.5%. Okay,
Yes, yes.
I will solve another example, more a difficult one. We will find, in this exercise, we will find the mass percentage of carbon in sugar. The chemical formula, the molecular formula of sugar, I don't know if you have learned it, is this one, C12H22O11. So what we will do in the first step, can you tell me?
You
In step
do,
1?
you find how many more per,
We will find the molar mass of sugar.
yes.
The expression will be 12 times molar mass of carbon. Why? Because we have 12 carbons here in the formula.
Yeah.
Plus 22 times the molar mass of hydrogen.
Okay.
Plus 11 the molar mass of oxygen. It's okay?
Yes. Yes.
So the molar mass will be 12. The molar mass of carbon is 12. The molar mass of hydrogen is 1.
1. Approximately.
Molar mass of oxygen is 16.
Huh? The molar mass of hydrogen is 11.
No, 1. Okay, I told you 1, but I wrote 11, sorry.
Yes, yes.
So let's check 12 times 12 is
Variable.
144
We add variable.
plus 22 plus 11, 11 times 16, 176. Molar mass will be 176 plus 22 plus 144, 342 grams per mole.
Left.
This is the molar mass of sugar, but what we want to find here is mass percentage of carbon. So in the step 2, the mass percentage of carbon is 12 times the molar mass of carbon. Why 12? Because we have 12 carbon atoms. Do you get it? Over the molar mass of
X.
times 100%. So 12 times 12 was 144.
X A plus X B.
Over
X A.
352.
X A plus X B. Yes.
144 over 342 times 100%. is 42.1
AX
percent
minus
in mass
BX.
carbon. So this is the mass percentage of carbon in sugar.
Okay.
You understand it?
Yes,
minus
I
BX
do.
Okay, if it was asked for hydrogen,
minus
it
BX.
would be 22
Yeah.
times 1 over, so it will be 22 over 342. If it was asked about oxygen,
D
it would
minus
be
D.
176 over 342. Okay?
There are two variables, A and C.
Yes.
Oh no, we can't. Can we backtrack up?
Okay,
Yes.
let's say another topic is to calculate the empirical
X.
formula. I don't know if you have learned, we have
X.
different types of
Open
chemical
brackets.
formulas.
A minus
Have you ever
X. A
learned?
minus C. Minus C.
Okay, wait a second, I will close the window.
C, not B.
My birds are singing a lot.
Yes.
Uh,
Yes.
Have you ever learned about chemical
Multiplied
formulas,
by A
types of
minus C.
formulas?
No.
Okay, we have different types of chemical formulas. The first one, the simplest one, is the empirical formula. This formula wrote here, empirical formula. The second
I
one
don't
is
think
the
so.
molecular
I don't think
formula.
that's what-
The third one is structural formula.
I do not think that is possible. Oh, I
Empirical
do not think that
formula
is possible.
is a chemical formula that expresses, remember this, or I will write it here. Empirical
Okay.
formula expresses the simplest ratio
Everything.
between
Yes,
the atoms or the elements in molecule or in the compound, in the molecule, in molecules, let's say.
D minus
So
D
you do
divided
understand
by
the simplest ratio?
A over minus C.
For example, I will write here something. The molecular formula or the chemical formula for a compound, let's say this one, is C2H6. This is the molecular formula of ethane. What will be the empirical formula? It will be CH3, because the simplest ratio is 1/3. 2/6 is not the simplest ratio. So do you understand it?
Yes, I do know.
Okay, how can we find the empirical formula of a chemical compound if we know let's say the mass percentage of the element in the compound, or if we know the mass for a given mass? Here is a solvent example. Look, what is the empirical formula of 26.6 grams nitrogen oxide that contains 9.8 grams of nitrogen? Okay, we have 26.6 nitrogen oxide with this chemical formula. We don't know the chemical formula and we will find it. We know that 9.8 grams are nitrogen. What will be the mass of oxygen.
Yes.
Of course, the difference of this with this. So the total mass is 26.x.
Yes.
What
The
will be the mass
minus
of
A.
oxygen? 26.6.
16.8.
16.8 grams of oxygen. Okay. Now what we will do, we will find the number of mole atoms for each element. So we can start with any of this, it doesn't matter. For example, number of moles of oxygen will be, what is the mass of oxygen? 16.8. What is the molar mass of oxygen? 16. So 1.05 mole
Equal to B minus A divided by P minus Q.
oxygen. For nitrogen, 9.8 over 14 is 0.7 mole atoms of nitrogen. Okay, what we will do in the second step? In the second step, we will divide the number of moles by the smallest number. Okay, which one is the smallest number between this and this? Of course, is 0.7. Isn't it? Yes. So we will divide with the simplest. So 0.7 divided
Yes.
or over 0.7 is 1. And 0.7 over 1.05 over 0.7 is 1.5. So the number of atoms must be expressed with positive number. So we will multiply each of these with 2. 1 times 2 is 2, and 2 times 1.5 is 3. So the empirical formula of the nitrogen oxide is N2O3. We will see another example. I will solve this one. Okay, we have a compound that is composed of 40% of carbon, 6.66% of hydrogen, and 53.34 grams of oxygen by mass. We will find the empirical formula. Okay, what we will do if we know only the mass percentage, but we don't know the exact mass of the compound, like the exercise before. We will take in consideration 100 grams of this compound. (100 grams). And so what will be the mass of carbon in 100 grams of this compound? Of course, 40% of 100 grams. 40% of 100 grams is 40 grams. 40% of 100 grams, 40%. So are you following me?
Yes, I am.
Okay. So in 100 grams of this compound with a known formula, we have 40 grams carbon. What will be the mass of hydrogen? 6.66% of 100, and it is 6.66 grams of hydrogen. And what is the mass of oxygen? Is 53.34% of 100 grams is 53.34 grams of oxygen. So in the first step, if you remember from the previous exercise, is to find the number of moles of each element, but to find the number of mole atoms. Look here, step 1. Find the number of mole atoms for each element. Let's start with carbon. What is the molar mass of carbon? 12 gram per moles. So number of moles of carbon, mole atoms, always is 40 grams over 12 grams per mole. It will be 40 over 12 is 3.33. 3.33 mole atoms carbon. Now with hydrogen, number of moles of hydrogen is 6.66 grams over 1 gram per mole. The molar mass of hydrogen mole atom for hydrogen. Now the last one, number of moles of oxygen. The mass of oxygen is 53.34 over 16 grams per mole. The molar mass, let's find it, 53.34 over 16.
Can I share my screen so I can easier to like put it because the space is limited.
3.33 mole atoms of oxygen. So this is the first step. Do you remember the second step? We will divide the simplest. We will divide with the smallest mole atoms. Each one of this.
The smallest.
The smallest is 3.33.
Is 1 to 1, like C to
Yes.
O.
Look, for
CH2O.
For carbon was 3.33 divided by 3.33 is 1.
No, sir.
Carbon.
You know why you have to share your screen, right?
For hydrogen.
There's a tiny arrow beside.
Is 6.66 divided by 3.30 is 2. And for oxygen is 3.33 over 3.33 is 1 oxygen. So the empirical formula of this compound will be C1. We don't write 1. H2O.
For the screen share. For screen sharing.
The empirical formula of the compound. So do you understand it?
Beside it. Beside it.
We will. I will solve another example to learn.
The host so I can show you.
We will learn another exercise. But let's start with let's continue with exercise 9. We will find the mass percentage of these elements in one of these compounds, and we will finish for today. Wait you in exercise number 1, choose anyone. Which compound do you want?
Oh,
A, B, C. Which one?
let's do from number 4, number 9, or I should just pick anywhere.
Which one?
I was planning on showing you how to share the
H,
screen, but I didn't
NH4 to SO4.
F.
You're muted.
Didn't
No, I
hear
picked
you.
Okay, I'm coming.
this one.
Tell me the letter.
Oh,
H.
oh, yeah. I can let you. Wait. No. So
Am I supposed to
I'm
pick
going
from number 9
let
or
you
number
share
4?
your screen now. Then I'll show you what I'm saying. Then I'll make
9. Which
Okay,
one?
from number 9, C.
Okay, C.
your host. Okay, so I'm going to ask for control so I can show you.
English, an official language in
Yes.
your country. Okay, we will find the mass percentage
Okay.
of each element in this compound. First of all, in the first step, we will find the molar mass.
You are welcome.
The molar mass
You are
of this
welcome.
compound will be, look, we have 2 nitrogens, one here and one here. So it will be 2 times the molar mass of nitrogen. Plus we have 4 hydrogens, 4 times the molar mass of hydrogen, plus 3 times molar mass of oxygen. Molar mass 2 times 14 the molar mass of nitrogen, plus 4 times 1 for hydrogen, plus 3 times 16 for oxygen. So 2 times 14 is 28, plus 4 is 32. 32 plus 48, it will be 80. 80 grams per mole.
It's taking so much time to annotate.
This is the molar mass nitrogen, ammonia nitrate. The name of this compound is ammonium nitrate. Okay, let's find the mass percentage of nitrogen. The mass percentage of nitrogen.
So what I did was I took 70
2
over to
times
the other side
molar
and took it to
mass
the other
of
side.
nitrogen
Then when I
over
had that, I
molar
got
mass
4p minus 7p
this compound
equals to
times
minus 3q
100%.
minus q minus. No, I'm talking about the other side.
2 times 14 over
When I did that,
80 times
I had
100%.
minus 3p equals to minus 4q. Then I divided by minus 3 on both sides.
So
I got q
28
equals to
over
minus 4q divided by
times
minus 3.
100% is 35.
Oh yeah, the minuses are going to cancel out.
So the mass percentage of nitrogen in this compound is 35%. So do you understand it?
Yeah.
Yes, Treasure?
My Q
Yes.
equals to
Okay. It's all for today.
12
Did
by
you enjoy the lesson?
Yes.
Yes,
4Q divided
I
by
did.
3.
Okay, so thank you
4Q
and see
divided
you.
by 3. Yes.
I wish you
You
all the
too.
best.
You too, sir. Thank you.
Bye.
Bye, sir.
Good night.